1, I'm going to use substitution to solve this system of equations. And remember, step 1, I want to get one of my equations with the variable by itself. And notice, I already have this equation with the variable by itself. And I'm actually going to write it out so hopefully you can see this a little bit better. I've got y equals 2x plus 1. That's my first equation. So remember, this is a system. It's two different equations. I'm trying to see when they are equal. And then in my other equation, I've got 3x plus y equals negative 9. And the reason I wrote the y's in blue is because this y is the same thing as that y. They mean the same thing. They're the exact same variables, so they must mean the same thing. So what I can do is I can take the fact that I know y equals 2x plus 1, and instead of writing a y in my second equation, I can write 2x plus 1. So what that will look like, I'll get 3x plus, and instead of writing y, but in that same spot of where the y was, I know since y equals 2x plus 1, and remember we always put things in parentheses when we plug them in, I can write 2x plus 1 equals negative 9. So notice, I rewrote this equation, but I didn't change it because y is the same thing, y equals 2x plus 1. So I can just substitute in or replace y with 2x plus 1. And here's what I was talking about earlier. The reason we do this is that now I have only one type of variable in my equation. I only have x's. So now a positive sign in front of parentheses doesn't change anything in front of them, so I can just drop the parentheses. I get 3x plus 2x plus 1 equals negative 9. First step, I'm going to combine my like terms. 3x plus 2x is 5x. Then I'm going to subtract 1 from each side. Remember, negative 9 minus 1 will give me negative 10. Divide each side by 5, and you get x equals negative 2. So now I know x equals negative 2. But remember, we're trying to find this point where the two equations are equal. So my final answer always needs to be a coordinate pair. So I've found the x value, but now I still need to find this y value. The way I do that is I take this x and I can plug it back into my second equation, or I can plug it back into my first equation. You would get the same answer either way. I'm going to choose to plug it into the first equation, so let's see what we'd get there. We'd get y equals 2, and I'm just going to substitute in negative 2 for x, because I know x equals negative 2, plus 1. Y equals 2 times negative 2 is negative 4, plus 1. And then my final answer ends up being y equals negative 3. Notice, had I used my second equation, so let's just see what would have happened. You don't have to write this part down, but I'm just going to show you what would have happened had we used our second equation. I would have 3 times negative 2 plus y equals negative 9. I would have had negative 6 plus y equals negative 9. Add 6 to each side, and I get y equals negative 3 as well. It's the exact same thing I got there, which means it does not matter which one you plug it into. I personally wanted to plug it into the first one because I thought that would be easier. If you would think the second one is easier, it would be just fine to plug x in there. You would get the same answer for y. And so my final answer, I just write in my y value. So what would the answer to the system of equations, when are they equal? They are equal when x is negative 2 and when y is negative 3, which means if I had a graph, they would cross at the point negative 2, negative 3. And that's all it is to use substitution. You solve one for a variable, plug in what that variable is equal to, solve, plug your answer back in, and solve again. And you get your two answers, which you write as an ordered pair.